Bayesian encoding. It is also known as Bayesian target encoding or empirical Bayes encoding. This encoding is based on Bayesian statistics principles. Bayesian encoding is a technique used to transform categorical variables into numerical values by considering the prior probability of a category and the posterior probability of a category given a target variable. Refer to the formula on how to calculate Bayesian encoding. The smoothing factor, K, is often interpreted as a prior weight, explicitly incorporates prior knowledge, a global mean, into the encoding. Encoding of each category is a balance between the category specific target mean and the overall mean of the target variable. The technique relies on Bayes' theorem to adjust the category's contribution based on how much data is available for that category, applying a form of regularization to reduce overfitting. Now, what are the advantages? Reduces overfitting, especially for rare categories. Captures relationships effective with imbalanced classes. A higher K will pull the encoded values closer to the global mean, which can be useful for categories with few samples to prevent overfitting. Now, what are its limitations? Can be complex to implement and tune, sensitivity to prior probabilities, and it requires prior knowledge about category probabilities. Less effective for small datasets. Now let's take a look at code sample.
Bayesian encoding. Here, I'll be creating one function. That's why I am using pandas and numpy. First, load the toy dataset in the data frame. Now, if we recollect the Bayesian encoding category, the formula is n star m plus k star g divided by n plus k, where n is number of samples in the category, m is the mean of target variable of the category, k is the prior weight, and g is the global mean of the target. Now we'll be implementing all this in our function. So the function that I am using here is taking data frame as an input, column that we want to encode, target, and here the prior weight I am using 1. First, calculating the global mean. Then I am calculating the category means by grouping each category and then aggregating for both count and mean. Both will be using here for the formula. So applying Bayesian encoding formula, this same formula. Here, the category means count times category means mean. K times global mean whole divided by category means plus k. So remember, k is 1 here. Now we create a dictionary for mapping based on this encoding, and then we apply a map function to map all the elements in the column and then return back the encoded column. So both temperature and color will be encoded using this function. Here I am using k is equal to 2. If we run this, this is how the encoded value would look like. Suppose I change the k as 1. You see the values are updated accordingly. Now, one important thing is we have to be mindful of how we set the K, because that's how the tuning need to be. And as I explained earlier, K impacts how these calculated means are moving towards global mean. That's all for this video. Thanks for watching. Don't forget to like, share, and subscribe for more exciting content on machine learning and AI.